Good afternoon, everybody. We're the Tilt Propulsion team. Today we have brought you our project. Our sponsor is Esoterra. So this is a drone that will transition from traditional flight to omnidirectional. So these arms will rotate between 90 degrees and then 90 degrees the other way, while also having thrust. So as you can see, we have a servo motor in the center. We went with the NEMA 17 just for the correct torque holding and everything. And then we have a gearing system right in the center here. It's a linear gear that sends the power from the servo over to both arms, and then to the beveled gear to rotate the arms.
Our main goal was to display a 90-degree angle tilt, along with the holding angle being 0.5 degrees of variance. We actually managed to surpass that and achieve a 180-degree tilt on both sides. Our next goal was to maintain 0.5 pounds of weight of one arm, which we actually managed to surpass as well, and have both arms be collectively 0.6 pounds.
As we went through our different prototype variations, we made improvements along the way. Some of these improvements included reducing vibrations. This was achieved by strengthening the material of these arms, which are now made of carbon reinforced onyx. Now we still do have some vibration, however, that is induced by the rotor wash coming off of our base, which is unfortunately just a constraint of the stand that we have. Another benefit of the carbon reinforced onyx is it adds a lot of strength to the arms, so we do not have a risk of these snapping under full thrust. Another issue we were running into on earlier models is some gear slop between the mechanism here. To improve this, again, we used onyx, which improves the print quality, and we also tightened up the tolerances in our CAD model, and that got rid of all of our slop. The last thing we did for an improvement was we changed our stepper motor. So our original stepper motor was much bigger and therefore heavier. One of the big constraints of this project is weight, as it's a flying object. So we sized down the stepper motor, and we were able to achieve the same results with a smaller stepper motor.
All right, to get this project connected, we connected an Arduino R4 to two electronic speed controller, and one stepper motor driver to connect to these two brushless motor and this one stepper motor. And it's being controlled by two potentiometers.